Hello everyone, today we're going to talk about chemical bonds, ionic, molecular, acids, how bonds are formed, and what keeps them together. So in the beginning of these videos, we're going to talk about the properties of elements versus compounds when they make these bonds. So as you see here, we're all familiar with sodium chloride, NaCl, salt, table salt. The two elements that make sodium chloride, you got sodium atom, you got the chlorine atom, they have two distinct properties to them. You got sodium, metal, solid, you got chlorine gas, and when they come together to make a reaction, you get sodium chloride. The point is that the properties of the individual elements are completely different when the two elements come together to make a compound, okay? So, one law in chemistry, and we've talked about laws when we looked at the scientific method in chapter 1. The law of constant composition means that no matter who the elements are, you will always have the same percentage of each element in that compound. We know water is always H2O. You have 2 hydrogens for every 1 oxygen. No matter if you have this much water, or a liter, or a gallon, or an ocean of water, you will always have a 2-to-1 ratio. So as you see right here, the law of constant composition, that in all samples of that compound will be made up of the same elements in the same proportion. Now, if you change those numbers not to be 2-to-1, maybe like 2-to-2 or 1-to-1, then you got a completely different compound. Even if the elements are the same, if you change the ratio, then you have a completely different compound. So how do we write formulas for chemical bonds, no matter what type of bonds? We do need to talk about a couple ground rules. So a chemical formula indicates who the elements are, who's the player of the game, and how many do you have of each one. Like for example, H2O, the formula for water, we know that we have hydrogen and we know we have oxygen. We know that this little 2 is called a subscript, and that 2 follows the hydrogen, which means that subscript follows the hydrogen. It only pertains to hydrogen. So the oxygen has no number in back of it, so it just represents 1. We never write 1s. It's kind of tedious. There's no point to it, because if you didn't have 1, you wouldn't have wrote the element to begin with. So H2O, the little 2, key vocab word called a subscript, and the subscripts are the little numbers. It tells us how many atoms we have of that element. So a couple things to think about when you're looking at the same elements but different subscripts, like 2 very different gases out there in the world. You got carbon monoxide, that's a 1-to-1 ratio, versus carbon dioxide, a 1-to-2 ratio. You still have carbon and oxygen, but you don't have the same proportion of carbon and oxygen. One is a 1-to-1, the other one's a 1-to-2. And I listed a chart right here in the video, so that way you can see the difference with it. Not only is the structure different, but the properties are completely different. So like for example, carbon dioxide, it's produced by combustion, decaying of organic matter, as in like when we burn fuel or stuff like that. Basically, we're polluting the world, and all that CO2 is what we are doing to produce. So we are producing that. But carbon monoxide, the combustion when too little oxygen is available, okay? Lighter or heavier than air, you got carbon dioxide that's actually over 50% heavier than air. But carbon monoxide is very light, okay, 2%. One of them is flammable, the other one is not. Carbon monoxide is very flammable. And can you detect it? Carbon monoxide is a very interesting gas because you cannot detect it through your eyes because it's colorless, and you cannot detect it through smell because it's odorless. So most people in their houses now, they are getting what's called carbon monoxide detectors. Looks just like a smoke detector, because that is basically the only way you can detect if you have carbon monoxide in your house. Carbon monoxide is known to be what's called the sleeping gas, because if you have maybe like a faulty heater or a water heater or anything like that, you could produce carbon monoxide, and because it's so light, it can rise, and basically it could cause some damage while you're sleeping, and unfortunately it could also kill. So you would not even know it is in your house unless you actually have a detector. Carbon dioxide actually does have a smell. If it's very highly concentrated type of gas, it does have a smell. And dangerous only if we keep producing more and more carbon dioxide will definitely start replacing the amount of oxygen that we have in our atmosphere. And carbon monoxide is definitely, as we said, very toxic, not only to your house, but people too. Same thing with like water, H2O. If you change one of those subscripts like H2O, maybe you make it a 2:2 ratio, that's hydrogen peroxide. Most of us probably know hydrogen peroxide, brown bottle in a bathroom sink. Use it to clean your ears, or if you have a little cut, you put a little hydrogen peroxide on it. But water, we drink. We use it to cook, water the plants. We do a lot with water. We're not chugging hydrogen peroxide, okay? You do not drink hydrogen peroxide. It could make you really, really sick, okay? Just because you have H and O in both compounds does not mean that they have the same properties, okay? So a couple ground rules on when you're listing the elements, like which ones go first, okay? So rule number 1, metals always go first, okay? So when we learned about the periodic table, which part of the periodic tables are which, there's 3 types of elements. You got metals, nonmetals, and metalloids. So metals are on the left side of what's called that zigzag line, and the zigzag line is right here in these green metalloids right here. So all of these blue elements are metals. So if I had any compound of one of these blue, they have to go first. And then after that, then you put a nonmetal, okay? So metals are on the left side, nonmetals on the right. And if I wanted to put 2 elements together like sodium and chlorine, well, I got sodium sitting right there on the left side, and I got chlorine over here, nonmetal on the right side. So as you see, sodium chloride, NaCl. You would not put Cl and then Na at the end. So metals always first, nonmetals at the end. Very, very clean, cut to the point type of rule. It's when you don't have a metal it can get a little tricky, okay? So in this periodic table, I put the little zigzag line in there to help you. So what if you don't have a metal, then the element that's more metal-like? Now, how do you know if the element's more metal-like? They're closer to the staircase. So like any of the metalloids, they would always go first over a non-metal. So like if I was going to bond arsenic with oxygen together, I'm going to put arsenic first because he is closest to the staircase. He's more metal-like than oxygen, okay? For example, like nitrogen and oxygen, because they're sitting right there next to each other, nitrogen is the one closest to the staircase. So I'm going to put nitrogen first, then the oxygen. So as you see right here between carbon and oxygen, you got the carbon sitting right there, very close to that staircase, and then you got the oxygen right there. Same difference. So the more metal-like always goes first, the non-metal still is in the end. Well, there must be a third rule coming about if there's no metal, and what if there's an element that's not close to the staircase? What if you got 2 non-metals, okay? So here we go. I put a little chart down here to help you get the hang of this. Within a group, so what if you have 2 elements in the same group? Remember, groups are the ones that go up and down. So these are groups, up and down, okay? So in a group, the elements towards the bottom are more metal-like than the elements at the top. And that should make sense. I mean, because look at these elements that are down here. You got metals, you got metalloids, and you have only a couple non-metals down here at the bottom. So any elements that are towards the bottom are more metal-like. So for example, if I have sulfur and oxygen, that sulfur right here is sitting right below oxygen, so I'm going to put sulfur first. No matter how many sulfur as oxygen you have, you put the sulfur first. So down here, this little table is a really nifty way of trying to figure out which one goes first also. If you get kind of like a little tiebreaker going on, it does help you. But be very careful of this one. Hydrogen. Remember, we got this hydrogen over here in the corner, and he's a non-metal. He should be over here with the yellow ones over here, but he's over in group 1 because of valence electrons. He only has 1, just like everybody below hydrogen. So be very careful with hydrogen because he does get a little sneaky right there in the middle of his order of the charts right there. Okay, but we'll practice this. So let's do 2 examples. And let's say you have the following number of atoms, and you have to figure out the correct order, okay? So I have 5 oxygen, and I have 2 phosphorus. Now I'm going to put my periodic table back up so that way it can help us. So 5 oxygen, 2 phosphorus, okay? So right here, I have my phosphorus very close to that staircase, and I got oxygen right here diagonally, okay? No brainer, that phosphorus has to go first. So I'm going to put my phosphorus first, always capital symbols if it's only one letter. And because I said I have 2 of them, I'm going to write it as in the subscript 2. And 5 oxygens, so I'm going to put a big O and then a subscript of 5 for oxygen. Okay? What if I have 3 elements? So I have 4 oxygen, I got 2 sodiums, and I got a sulfur. So I'm going to put our periodic table back up. And let's try to figure out which one goes first. And this was what I had. I had oxygens, I had sodiums, and I had sulfurs. Okay? So first, always look, do you have a metal? And I absolutely have a metal. I have a metal right there, sodium. So sodium has to go first. Now it comes down to who goes next, the oxygen or the sulfur. And remember, they're sitting right here. So the element that's closest to the bottom, if you have 2 elements in the same group, the element closest to the bottom is more metal-like, so he goes next. So the sulfur is going to go second, and then the oxygen is going to go at the end. So we're going to put our sodium, and we said we had 2 of them, so we're going to put a little subscript 2. And now we know that sulfur is going to go next, capital S, and we only have 1, and we don't write any 1s. And then we have our oxygen, capital O, with a 4 as a subscript. Okay? So as you go through these videos for chemical bondings, we're going to get into more detailed rule, but this is the very first beginning part of how to write a chemical formula. Hopefully it helped, ladies and gentlemen, and I'll see you on the next one.